All right, here we have the chemical reaction lab and just a few hints I'm going to give you in this video to help you with that. So you got to see some reactions or at least get description of reactions. And this is something we're doing all the time, trying to figure out how to process it, what's going on at the molecular level, and then communicate that. So I'm going to look at reaction 1 and experiment 1. And hydrogen peroxide breaks down into water and oxygen. Okay, without thinking, probably the most common thing to say is it breaks into hydrogen and oxygen. You did a glowing splint test, which relit, which confirms oxygen. Okay, a burning splint popping would confirm hydrogen. That didn't happen. So you confirmed oxygen, you don't have hydrogen. So this is actually the balanced equation for this. Okay, I like this one. It talks about what's oxidized and what's reduced here. So I look at this and I got the hydrogen and the oxygen here, and hydrogen's +1 over here and hydrogen's +1 over here. Doesn't look like anything's happening. Oxygen is usually by itself, no charge, or in most things it's -2, but in peroxide, primarily hydrogen peroxide or maybe like sodium peroxide, okay, you get a -1 charge. When it breaks into water, it goes from -1 to -2, and also it goes from -1 to 0. So this oxygen in the hydrogen peroxide is both reduced, going to H2O, and oxidized, going to the O2. So when one thing is both oxidized and reduced, you'll find that that is a disproportionation, and that's what's happening there. And again, I think hydrogen peroxide case is good to know because it's a common substance and it has this exception. And it seems like we talk about that a lot. I'm going to break this into half reactions. I'm going to take the H2O2 and I'm going to do the oxidation half reaction. So when it goes from -1 to 0 in oxygen, 2 oxygens here, 2 oxygens here, it gives off 2 electrons. Now I'm going to take the H2O2, it goes to 2H2O, so I put the 2 there to balance the oxygens. I have a -1 here, it goes to -2, so it is actually being reduced. It gains 2 electrons in that process. Notice how this adds up. If we take the 2 electrons here and 2 electrons here, they cancel each other out. We end up with our original equation, 2H2O2 forms 2H2O plus O2. So that's kind of a tricky one with hydrogen peroxide, but again, the hydrogen peroxide example is used quite a bit, so it's good to know about that. There's another part of a disproportionation besides one thing breaking into 2 different charges, and it's kind of the opposite here. Iron has no charge, it's an element in its natural state. Iron's +3 here. Now it goes to somewhere in between a +2 state right here. So you can see going in the opposite direction that happens. I don't really think of the hydrogen peroxide as very much a reversible reaction in a practical sense, but these 2 reactions tend to be more reversible types of reactions. Okay, so experiment number 2, I don't think I need to give any hints. I hope you all enjoyed precipitating in this reaction. Okay, experiment number 3, I don't know if you can see this up here. Are all oxidation numbers whole numbers? No. So, if you're trying to get a whole number for carbon, you're not going to get it. You might get some weird fractions with your oxidation numbers. Ultimately, things should balance out when you do your equations, but to be neutral substances to make this neutral. But you won't have every oxidation number being a whole number. Okay, let's see. Number 4 is the single displacement reaction. And I would look at the activity series in the reaction types guide. So look at that when you're getting to this part. Okay, some are going to be no reactions. Remember your activity series when we work with that, and that is in that reaction types guide. Okay, number 5, the synthesis reaction here. I'm trying to think if there were any hints. I don't think I had any particular hints with this one. Number 6 is, just remember when you're doing this reaction, make sure you get the right formula for sodium bicarbonate. So think about what that really is. Okay. The other thing is when you do these different reactions, I think we got the decomposition reactions. These aren't breaking up into ions. Okay. These are breaking just into whole things. So your overall equation, or if you set down ionic equations, it's going to be the same thing, but this one doesn't break into ions. All right. I hope these hints help you in your process. Think about these things, look up things as needed, and connect with your peers and use this lab as a good learning opportunity to learn more about reactions. Thank you.